So in this video, I'm going to go over game 4 from Prep Test 63. So 1 second, I just have to look it up here. Game 4, okay. Great, okay, so yeah, this one's pretty tricky. It's a little unusual, so there's sequencing for sure. That's an element of it. Because we have these 6 boxes and we're trying to figure out what's in each box, but they're in like a particular order. And we do see the word lower and the word in, below, like lower and below, so those would indicate a sequence. Now this is a vertical sequence rather than our usual horizontal sequence, so that makes it kind of tricky. The lowest box is labeled 1, then 2, 3, 4, 5, and 6, up to the highest. Okay. But then we're figuring out what's in each box. And yeah, it gets a little bit tricky because we don't have a 1-to-1 ratio of players to positions. So we have 3 players, which are just the colors of the balls that are in these boxes. Each box contains a single ball, so we are just kind of ordering these along a sequence. But because there isn't a 1-to-1 ratio, there's a bit of what you might call like a numbers issue here, or a distribution issue. Okay, so how do we distribute these 3 players among the 6 positions? Okay, so we're going to have to make some deductions about that based on the rules. We're told that there are more red balls than white balls. So rather than just saying that, you know, the number of red is greater than the number of white, and moving on to the next rule, I want to see what my options are there. So typically when I do have a distribution issue, I am wondering about, you know, how many of each could I have, what's possible. So at this point, we don't know that we have to have at least 1 of each color. So it's possible that we have like 5 red and 1 white, right? But that would be the absolute extreme. We could have 4 red and 2 white, but we can't have 3 white. So white is a lot more limited than red. We know red has to have a minimum of 2. Although I suppose if we had 0 white, then we could have just 1 red. So, I mean, there's a possibility. But we definitely know that for white, we can't have 3 of them, because then there are only 3 balls left. Even if all of them are red, they would be equal. So the number of white balls would be a maximum of 2. All right, rule 2. And the other rules might actually illuminate these as well, right? So I have said that there's a minimum of 2 here. And the reason I have left that there is because we find out later that there has to be at least 1 white ball. So there have to be at least 2 red balls. Okay, so there's a box containing a green ball that is lower in the stack than any box that contains a red ball. So there's at least 1 green, okay? So a box containing a green ball, at least 1 green lower than any red. Okay, so however many reds there are, there's at least 1 green that's below them. That doesn't mean that all the greens are below the reds, just that there's at least 1 green that's below all the reds. So there could be a green up here as well. That's fine, as long as there is at least 1 green down at the bottom before we start getting reds. And then rule 3, there's a white ball in a box immediately below a box that contains a green ball. So we do have this configuration at least once. Okay, so that would be a minimum of 1, and that's also a minimum of 1. Okay, so that configuration has to happen at least once. So, I mean, one quick example would be just putting this configuration right at the bottom, and then the rest of them are red. That could totally work. We could also replace one of these reds with a green or a white, so that's fine. We don't need to have this configuration every time we have a white ball or every time we have a green ball. So we don't have any conditional indicator words in that last rule, whereas for the second rule, the conditional indicator word any, right? So anytime there's a red ball, there has to be a green ball somewhere lower than it, right? So we can't have red, the first one. Okay. So the first one, if the first one is white, then let's see, we could have red, 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 white, green. That's possible, right? We could have white, green, green again, red, red, green, right? So we always have to make sure that our reds outnumber our whites, right? So even though we have to have a green in there, it's still possible to have 2 white because the rest of them could be red, and that would be 3 red. So we have a bunch of acceptable solutions here. And I do like to create a few just diverse acceptable solutions when I'm dealing with a game that's a little bit odd, that I don't quite understand fully or intuitively just based on reading the rules. I want to understand at least some of the possibilities. Okay, so let's just do a couple of the questions. So question 18, if there are exactly 2 white balls, so if we have 2 white, we know we have to have more red. We know we have 1 green at least, so 3 red is what we have to have. So this is going to tell me the distribution, which is really handy. I need a green before I get any red, right? So I'm going to need a green somewhere in here. I'm leaving these 3 open because I have to have at least 3 red. So the highest that I could put a green would be the 3rd box. I also know that we're going to have the green directly above a white because it's the only green we have, and we have to have this occurring at a minimum 1 time. We actually can't have it occur twice. So if we have it occur twice, then we would only have 2 spots left for red, and our white balls would equal our red balls. So this is actually going to be exactly once. So that was just kind of a quick diversion to show that. So that is not possible. Okay, so back to this question. So the green has to be above a white, so it can't be in the first spot. Okay, so it's either the 2nd spot or the 3rd spot. Box 3 is the only option that's there, because if box 2 was an option, that would also be the correct answer, right? So box 2 and 3 could contain a green ball, that would be fine. So we could have white, white, green, red, 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 with green in box 3, that's an acceptable solution. Or we could have white, green, red, red, white, red, or put the white anywhere else, right? The white ball could jump in any other position as long as we keep green in the 2nd place. That's what we're trying to show. So those are both acceptable. Oh, sorry, and then I just did that all off screen. Okay, so hopefully that gives you a little bit of time to kind of catch up on what I was talking about there. Okay, I'm going to do one more question. All right, so let's do question 19. If there are green balls in boxes 5 and 6, so 5 and 6 are the top ones. So we have green and green, and then there's going to have to be another green because we need to have a green below the red. So we're going to have 3 green for sure, and then we have a minimum of 2 red, and then we would have 1 white. So again, I'm figuring out how many of each I have before I start placing them, before I would look at the answer choices, right? When we have a question specific condition like this, you know, if there are green balls in boxes 5 and 6, we want to deal with the deductions that we can make from that first before we look at the answer choices. Okay, so this is 5, this is 6, 4, 3, 2, 1. We need to have green, white. So we could have this green and then a white and then red, red, green. That's fine. Or we could have green and white here, and these two could be red and these be green. Those are our options. Okay, we do need to have a green before the reds, right, below the reds. And we need to have green and white together in that arrangement once. All right, so what could be true? All right, there are red balls in boxes 1 and 4. Nope, that's not gonna work. We can never have red in 1, right? We're never allowed to do that because there has to be at least 1 green below all the red. Red balls in 2 and 4. No, so we can't split them up like that because then we're not going to be able to have our green directly above white. So not A, not B. There's a white ball in box 1. Yep, that's possible. So C is the answer. D and E are not possible. We can't have white in here. We could have white in 4, but that's not an option. Okay, so hopefully that gives you a good idea of how to continue with this game. If you have any further questions, just let me know.